In this lecture, we're going to learn about weak pointers. And weak pointers are another kind of smart pointer we have in C++. They are special in that they don't own the data that they point to. So if the weak pointer goes out of scope, the memory they pointed to is not going to be released. So they don't own the memory. Another thing that is special about weak pointers is that they don't have the pointer access operator or the dereference operator. In other words, you can't use them to read or write into the data that is pointed to by the pointer. Okay, so some of you must be asking, if I can't use the pointer to read or write into my data set, why do I need this pointer? Okay, I understand your question. But before we address that, we're going to see how we can use these pointers. Here we have a simple example, and we have two shared pointers set up on top here. And we are using std_make_shared to dynamically allocate memory on the heap. We have a dog object and we have a int variable here, which is pointed to by this pointer here. And this is something you already know. Down here, you see we have a pair of weak pointers. This is the syntax you use to set them up. You say std weak ptr. You put a pair of angle brackets, and inside you put in your type. You pass the variable name, and then you initialize this weak pointer with the shared pointer. This is something we can do. And this is going to set up another pair of pointers pointing to the same data we had before, but these pointers can't really be used to read or write data. So they have no dereference operator. They also don't have the pointer access operator. And if you try to go through these operators to access the data through the weak pointer, which is what we are doing here. For example, here we want to print the dog name. If we use the pointer access operator here, we're going to get a compiler error saying that we have no such operator on this pointer here. If we try and use the dereference operator, just like we are doing here, we're going to get a compiler error saying that we have no such operator. And we have no get method on the weak pointer because it's really not meant to be used to manipulate data. So if you really want to use a weak pointer, you have no choice but to turn it back into a shared pointer. And you do that by using the lock method. For example, here we have a shared pointer to dog. And we are saying its name is weak turned shared. And what we are going to do to assign data back to this shared pointer is to call the lock method on our weak pointer. This is going to turn what we had in our weak pointer into a shared pointer. And after this, we can use this shared pointer like we use any other shared pointer in our C++ code. For example, we can get the reference count as we do here. We can use that to get the name. And you are going to see that we get the same name we had in our shared ptr dog1 on top here. That's what we're going to see down here. So this is how you can use a weak pointer. It doesn't own the data it is pointing to. So if for some reason the weak pointer here goes out of scope, this is not going to decrement the reference count, and this is not going to cause for the memory to be released. Okay, so now that you know how to use a weak pointer, let's talk about where it is used. Because we have seen that you can't really use it to access the data that is pointed to, you can't use the dereference operator or the pointer access operator. So there must be some use for the weak pointer. And the main purpose of creating this type in C++ is to solve a problem referred to as cyclic dependency problem. And to explain that problem, we're going to look at this class here. The class is called person. And if you go down in the member variables, you're going to see that we have a member variable which is going to store the name for the person. But we also have a shared pointer to person, which is going to be pointing to the friend of this person object here. So once we have a class like this, we can create objects of this class. So we can create the first object to be person A. It is what you see here. And we're going to use std_make_shared to allocate space on the heap. The name is going to be Allison. And we're going to create a second person object, which is going to be person B. The name is going to be Beth, as you see here. And then we are going to set person B to be the friend of person A, as you see here. And we're going to set up person A to be the friend of person B. So this is the setup we do. So the situation here, we're going to have person A pointing to person B, and we're going to have person B pointing to person A. This is going to give us the situation we see here. So person A, the name is going to be Allison. They are going to have a shared pointer member variable, which is going to be pointing to person B. And we're going to have a person B, whose name is going to be Beth. And they are going to have a shared pointer member variable, which is going to be pointing to person A. The problem is going to come when these two guys are about to be released from memory. So the C++ runtime is going to try and deallocate person B, for example. When it tries to do that, it's going to find that we have a person A who is still pointing to person B. This is going to prevent the reference count from decrementing all the way to 0 to cause for person B to be released from memory. So the person B shared pointer is going to go out of scope. So this is going to be destroyed, but what is pointed to is not going to be destroyed. This thing is going to stay in memory. So the C++ time is going to leave the scene. Then it's going to be a turn for person A to be released from memory. And when the compiler tries to delete this, it's going to find that we still have a pointer pointing to person A here. So the reference count is not going to go down to 0 because somebody is still pointing to person A here. So the pointer itself is going to go out of scope, but the data that we are pointing to in memory is not going to be released. So the program is going to end and we will be leaking the memory for person A and person B here. This is the problem we might have if we try and use shared pointers as member variables for our person class here. So the problem is we have a member variable which is going to cause for the reference count to be incremented if this guy is still around, and that the reference count is never going to decrement all the way to 0, and we're going to leak memory. Our pointers that we have on the next slide right here. So we are going to see the pointers here are going to go out of scope. They are going to be destroyed, but the data on the heap is not going to be destroyed. It's going to stay there. And we are just going to leak this memory because we are using a shared pointer member variable. I hope this makes sense. And one way to solve this problem is to change our class and change the member variable to be of weak pointer type and not shared pointer type. Because this weak pointer is not going to be incrementing the reference count, we're not going to have the same problem here. The reference count is going to be decremented all the way to 0, and we're not going to leak memory. The destructors are going to be called for person, and the problem is going to go away. Okay, now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Okay, so here we are in our working folder. The current project is weak pointers. We're going to grab our template files. We're going to put them in place. And we are going to put them in our folder here on weak pointers. And we are going to steal the dog class from a previous lecture. Let's do this. And we're going to put this in. And we're going to open this little guy in Visual Studio Code by dragging and dropping here. This is going to give us our thing, but we still need the person class. So let's put this in. We're going to put in the header, person.h, and we're going to put in place person.cpp to be our implementation file. I am going to grab the code I have lying around on my drive for person here because I don't want to type all this. It is a simple person class. And we have a pair of constructors, we have a destructor, we have a member function which is going to set the friend, and we have two member variables. One is going to store the name for the person, the other is going to store a shared pointer to a person, and that's going to be the friend of the current person object here. We can set this friend through the setFriend member function here, and the member function is going to take a shared pointer by reference, and it's going to set that guy as our friend here. And this is really all the class here is doing. We are going to hop over to the implementation file and put in the implementation for the constructor and the destructor here. And this is going to be all we need here. We can hop over to the main CPP file, clean it up a little bit, and we're going to include our headers. The first one we need is memory. To give us access to smart pointers, we're going to need the dog class. Let's put this in. And we are going to need the person class that we just put in here. The first thing we're going to do is set up a pair of pointers. We're going to set up a pair of shared pointers to either dog and int. And we're going to use std make shared to create these things on the heap. We're going to have dog1 and a value of 200 stored somewhere on the heap. And we're going to have these pointers managing our heap memory here. So this is something you already know. But we can go through the shared pointers here and create weak pointer objects here. So the syntax is std weak ptr. As you see here, we're going to put our type in angle brackets, and we're going to give our weak pointers variable names. And we're going to use our shared pointers to create weak pointers that are going to be pointing to the same memory location here. But one might think that these pointers are really useless, because if you try to use them directly, you're going to be getting all kinds of weird compiler errors. And we are going to get these weird compiler errors because weak pointers don't have the operators you would expect any pointer to have. For example, we don't have a pointer access operator. We don't have a dereference operator. We can't even call the get method like we did on other smart pointers we have learned about so far. So if we try and build this program here, we're going to get these weird compiler errors. Let's wait and see. We're going to see the build is going to be with errors, and we're going to be told that we have no such operator here. Okay, so we have no pointer access operator, we have no dereference operator, and if we try to use these guys, we're going to be getting compiler errors as we see here. So let's comment this out because we want the code here to compile. So we're going to do this. And if you want to use a weak pointer, you have no choice but to turn it back into a shared pointer. But that's possible. Okay, so for example, we can go down here and set up another shared pointer, and we're going to be using the weak pointer and calling the lock method on it. This is going to change our weak pointer into a shared pointer, and from this point on, we can use this shared pointer to do all kinds of crazy things. We can get the reference count printed out, we can get the name for our dog object, and we can even go through the original shared pointer that we had on top, and we're going to see that we get the same name printed out. So let's build and run this program because I want you to see this. The build should be good. So the build is good as you see here. We're going to bring up a PowerShell window, and we can clear and run Rooster. You're going to see that the dog name is dog1, the dog name is dog1, and the reference count is 2 because now we have two shared pointers pointing to the same memory location. We have shared ptr dog1 and we have weak turned shared, and they are pointing to the same memory location. That's why we have a reference count of 2 on our dog object here. What is going on? Let's run this program again. We're going to clear and run Rooster, and we should have a reference count of 2, and if we print either through weak turned shared, we're going to get the same name here, dog1. If we go through the original pointer, we're going to get dog1, and we're going to hit the end of the main function, and this is going to bring the shared pointers out of scope. And this is going to cause for the destructor for dog to be called, and we see that called here. This is what we expect. Okay, so now you can't really use weak pointers directly in your code. Why would you even need them? Well, the main purpose for them is to solve the cyclic dependency problem. And we will have this kind of problem if we have two objects pointing to each other. So remember, we have a person class. So we have a pair of shared pointers to person, and person A is going to have the name Allison, person B is going to have the name Beth. They are going to be heap objects managed by these shared pointers here. And if we go down here, we're going to set up person B to be a friend of person A, and we're going to have person A be a friend of person B. What this is going to set up is for person A to have a pointer to person B, and for person B to be pointing back to person A. And remember, these are shared pointers, and in our member variables, the member variables are modeled as shared pointers. So these are going to bring up the reference count if you happen to be having them pointing to each other. So suppose we are at this point here and we are hitting the end of the main function and we want these objects destroyed. So the first object to go out of scope is going to be person A, and the C++ runtime is going to try and destroy person A here. But it's going to see that we have person B pointing to person A. And that's going to prevent the reference count from going down all the way to 0 to cause for person A, the object here, to be destroyed from memory. So the shared pointer itself, person A here, is going to go out of scope, but the object, the real person object, is not going to be destroyed because we still have a pointer pointing to it. So this is not going to be released. Person A is not going to be released from memory. And we're going to go to person B and try to release this from memory. But we will have person A pointing to person B, so the reference count is not going to go down to 0 either for person B. So the shared pointer itself, person B, is going to be destroyed, but the person B object in memory is going to be left in there. So the program is going to end and we will be leaking the memory we have for Allison and Beth here. And this is really bad. The reason is we have member variables which are modeled as shared pointers, and these are reference count incrementing pointers. So we need something that is not going to bring up the reference count for these objects to be truly destroyed from memory. And the fix is really simple. All we have to do is change the member variable here to be a weak pointer, and it's not going to be a reference count incrementing pointer. So this is no longer going to prevent our object to be destroyed because the reference count is going to go down to 0 once we destroy these objects here. But before we show you the fix, let's try and build and show you the problem. I think we should comment out all the rest because we don't want these things getting in our way. So we are going to go up and comment out the code we had here. Let's do this. And we are going to go all the way to the top and comment out the other objects that we had created. I think they have served their purpose. And we can build now. Let's pass this through GCC. The build is going to be good. As you see here, we can clear and run Rooster. Now you're going to see that we call the constructors for Allison and Beth, but the destructors are never called because these objects are really not destroyed from memory. All that is destroyed are the variables person A and person B. Remember that these are just shared pointers, but the data that they point to, which is really these objects here, is not going to be destroyed, and this is really bad. Again, as I said before, the fix is really simple. All you have to do is change the pointer here to be a weak pointer. And that's going to be a pointer which is not going to increment the reference count. It's just going to be a pointer sitting in your class here. And if you happen to need to use this pointer to manipulate the data, we have seen that you can turn this back into a shared pointer, no problem. But in this case, it's not going to cause any problem because it's not going to increment the reference count. So if we build now, the problem is going to go away and we will see our destructors called. This is going to be really cool. Okay, so the build is good. We can clear and run Rooster. Now you see that the constructors are called and the destructors are called, and we are no longer leaking memory. This is the only useful use case we have for weak pointers. If you don't have cyclic dependencies in your code, you're never going to need weak pointers, but I really had to show you this to make this chapter a little more complete, because it wouldn't really be complete if I didn't talk about weak pointers. But you're not going to need them that much. In practice, what you're going to be using a lot is a unique pointer, and sometimes you're going to be using shared pointers, but you're going to be making the decision yourself on which kind of pointer you want to use in your C++ program. So some C++ developers are going to go as far as saying you should never call the new operator in your C++ code. You should never call the delete operator to release memory explicitly. You should always use smart pointers to manage your memory. But there is a lot of code sitting out there in the wild. I wouldn't go that far and tell you that you shouldn't really never allocate memory yourself. Please take some time to think about the project that you are working on and decide for yourself if you want to use smart pointers or not. Because these are just tools we have in C++, and you have to use what makes sense for the kind of problem you are trying to solve with C++. This is really all I had to share in this lecture. I hope you found it interesting. We are going to stop here in this one. In the next one, we're going to try and recap what we saw in this chapter. Go ahead and finish up here and meet me there.